I'm Miss Frost, and today we're going to be learning about the greatest common factor and the least common multiple.
Miss Conley, do you hear that?
What is that?
I don't know.
What?
Ding, 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 Factor Ninja Warrior game.
I will defeat you. Victory!
The Factor Ninja chops up the products. Our product here is 12. The Factor Ninja then chops it up into 3 and 4, the factors of 12.
Today we're going to be talking about the greatest common factor, but before we do that we need to know exactly what a factor is. So a factor is just the numbers that you multiply in order to get a product. For example, if we were trying to find 12, the factors of 12, we would multiply 3 and 4 because those give us 12, and then 3 and 4 are some of the factors that get us to 12. There are a couple of others, so there's also 1 and 12, and finally 2 and 6. So all of these underlined numbers are actually the factors of 12.
Since we now know what a factor is, we can talk about common factors. A common factor is a number that is a factor of two different numbers. Let's say we have 6 and we have 12. Two different factors of 6 are 2 times 3, which gives us 6, and 1 times 6, which gives us 6. For 12, we have 3 times 4, 1 times 12, and 6 times 2. If we look at all of our factors, which for 6 are 2, 3, 1, and 6, and for 12 are 3, 4, 1, 12, 6, and 2, our common factor would be a factor that both of our numbers 6 and 12 share. In this example, both of our numbers have a 3 and have a 3, which means our common factor of 6 and 12 is 3.
So not only is 3 a common factor between 6 and 12, but you can also notice that there's a 1 on both of them, and there's also a 6, and there's also a 2. So these are all of our common factors for 6 and 12. So now that we've talked about what a factor is and what a common factor is, now we can figure out what the greatest common factor is, or the GCF, between these two numbers. So you'll often hear this called GCF, and that stands for greatest common factor. So if all of these numbers right here are common factors between 6 and 12, we want to find the greatest one. So that would be the largest, or the biggest one. And between both of them, we have a 1, 2, 3, and a 6. And obviously, our 6 is the biggest number that both of the numbers share. So that would be our greatest common factor. So now what we would like you guys to do as a group is just kind of talk to each other and talk to each other about the differences between a common factor and the greatest common factor, and how might we find that greatest common factor as well. And when you're ready, come back and join our video. Now that we know what a greatest common factor is, let's talk about some strategies on how to find it. So the first strategy that we're going to look at is very similar to what we just did, and it's called the list. So if we are using our numbers 12 and 24, we're going to find the factors of that, and remember, factors are the two numbers that you would multiply to get that number. So I know that 1 and 12 multiplied together to get 12, so those are both factors. 2 and 6, and 3 and 4. So those are all my factors for 12. And my factors for 24, we have 1 times 24 equals 24. 2 times 12. 3 times 8. And 4 and 6. So those are all of my factors between 12 and 24, and now we want to go through and circle those common ones. So there's a 1, 2, 3, 4, 6, and 12 in each of my factor lists. So now that we want to find the greatest common factor, we want to look at which factor is the biggest out of all of those common factors, which happens to be our 12. So our GCF for 12 and 24 is 12. So now that you've learned the list strategy, we want you to go ahead and try this. So go ahead and pull out your paper and pencil, and we want you to go ahead and use this strategy, the list strategy, to find the greatest common factor between 6 and 8. So go ahead and pause this video and work on that. Welcome back. So let's go ahead and review what work you finished here, and we can find out the answer. So for the factors of 6, we have 1 times 6 equals 6. And we have 2 times 3. So those are all of our factors of 6. And our factors for 8 are 1 and 8, 2 and 4. There's a big gap, but that's okay. So if we look, our common factors between them are 1 and 2. And the greatest common factor between these two numbers is the 2.
The next strategy we can use to find the greatest common factor is a factor tree. To show a factor tree, we're going to start with the number 12. Our factor tree will help us break down our numbers into smaller numbers. So for 12, we know that two factors of 12 are 2 and 6. Since we can't break down the 2 anymore, we're going to go ahead and circle it. We can't break it down anymore because 2 is a prime number, which means that 2 can only be multiplied by 1 in itself. So the only factors of 2 are 1 and 2, so we're going to circle that and leave that just like it is. But we can break down 6 even further, and we can break down 6 into 2 times 3, and we know 2 is a prime number, so we can circle that, and 3 is a prime number as well, because the only factors of 3 are 1 and itself 3, so we will circle the 3 as well. Now we can bring down our broken down numbers to the bottom, so we know 2 times 2 times 3 equals our product of 12. Our next number will be 24. We are also going to use a factor tree to break down 24. So I know that two factors of 24 are 4 and 6. Neither of these are prime numbers, so I'm going to keep going. 4 can be split into 2 and 2. And I know that these are prime numbers, so I'll circle those. And I can't break that side down any further. Next, for 6, I can break 6 down into 2 times 3. And once again, I know 2 is our prime number, and I also know 3 is a prime number, so I'm going to circle both of those. Now I find it helpful when writing down our broken down numbers to do it in numerical order, so starting with the smallest and ending with the largest. So I have 3 2's, so I know 2 times 2 times 2 times 3 equals 24. Now that we have 12 and 24 broken down, we can use our broken down forms to find the greatest common factor. So first we're going to look and see what 12 and 24 broken down have in common. So I can see already that they both have a 2. They also both have another 2. And they have a 3. I'm not going to circle this 2 because 12 does not have that in common with 24. So now that I know that in common they have 2 times 2 times 3, I can go ahead and multiply that out to get that greatest common factor. So I know 2 and 2 is 4 times 3 which equals 12. So together, that means our greatest common factor of 12 and 24 is equal to 12. For our next example, go ahead and grab your sheet of paper and pencil and follow along for reference notes as we go along. So our next example for greatest common factor is 10 and 56. First, let's use our factor tree to break down 10. I know that 10 is split into 2 and 5 because 2 times 5 equals 10. I know 2 is a prime number, and 5 is a prime number we haven't seen yet, but the only factors of 5 are 1 and 5, so we can circle that because we know 5 is a prime number as well. So we can't go any further with 10, so our broken down form of 10 is 2 times 5. Next, let's look at 56. I know that two factors of 56 are 7 and 8. I'll have to think about 7 for a second, but I know that it's a prime number because the only factors of 7 are 1 and 7. So I'm going to circle that because it is prime. But 8 I can break down a little bit further. So I know that two factors of 8 are 2 times 4. 2 is a prime number, so I'll circle that. And then 4 can be broken down into 2 times 2. And both of those 2's are prime numbers. So I know broken down, 56 equals 2 times 2 times 2 times 7. So to find our greatest common factor between 10 and 56, we'll look at those broken down forms. And remember, we want to find what these two have in common. So I can see that they both have a 2. 10 also has a 5, but I don't see a 5 in the broken down form of 56, so I won't circle the 5. I also won't circle the 7 because there's no 7 in the broken down form of 10. So it looks like all I can circle here is the 2, which means our greatest common factor for 10 and 56 is 2. Next, we're going to have you try to find the greatest common factor independently. So we're going to give you two numbers, 48 and 64. You can use either strategy that you like better to try to find that greatest common factor between 48 and 64. If you are finished before your peers are done, try another strategy and see if you can use both. When everybody is finished, discuss your strategy and how you came up with your answer in partners or groups, and then you can unpause this video. Great job finding the greatest common factor of 48 and 64. Let's go through a few strategies of how you may have solved this. So 48 can be split into 6 and 8 because I know 6 times 8 gives me 48. 6 can be split down into 2 times 3 because 2 times 3 is 6. And I know that 2 and 3 are both prime numbers, so I can go ahead and circle those. Now I know that 8 can be split into 2 times 4. I know that 2 is a prime number, so I'll circle it. And 4 can be split into 2 times 2, which are also both prime numbers. Now I'll write out this form right below my factor tree. So I have 1, 2 times 2 times 2 times 2 times 3. Now I'll go ahead and move over to 64. 64 can be split into 8 times 8. I'll start with one of my 8's, which can be split into 2 times 4. 2 is a prime number, so I'll circle it. And 4 can be further split into 2 times 2, and I can circle both of my 2's. The 8 on the other side will be the same thing, so 2 times 4, and circle my first 2. 4 can be split down into 2 times 2, which are both prime numbers, so that is the end of the factor tree for 64. Now I'll write out all of my factors, so I have 2 times 2 times 2 times 2 times 2 times 2. So there's a lot of 2's in 64. So to find my greatest common factor, we know that we can circle all the factors that 48 and 64 have in common. So there's 1 2, 2 2's, 3 2's, 4 2's. Then I have a 3, which I don't have in 64, and I also have 2 extra 2's, which I don't have in 48, so we'll leave those alone. So I know my greatest common factor is equal to 2 times 2 times 2 times 2, because 48 and 64 have all of these 2's in common. I know that 2 times 2 is 4 times 4, which is equal to 16, which means our greatest common factor between 48 and 64 is 16.
So now we're going to look at the list strategy. So if you solved it this way, we'll go over this. So we're finding 48 and 64. So using our list strategy, again, we have to find the numbers that we multiply together to get to the 48. So we know 1 and 48 multiplied together are 48. 2 and 24. 3 and 16, 4 and 12, and 6 and 8. So that's our entire list of factors for the number 48. For 64, we know 1 and 64 multiplied together give us 64. 2 times 32, 4 times 16, and 4, and 8 and 8, but we only need to write one of them. So now we'll go back through our list and circle all of the common factors between 48 and 64. So there's a 1, a 2, 4, 8, 16, oops, and that's it. So when we're looking for the greatest common factor, we want to find the number that is the biggest. So there's 16, 8, 4, and 2, and 1. And obviously the biggest one is 16. So our greatest common factor is 16. Now that took a lot of work because it took me a while to remember everything that, all the factors of 48 and 64. So sometimes the list method, while it might be a little bit easier, for some people to understand, it may take a little bit longer to actually complete.
Man, Miss Conley, those factor ninjas were crazy.
You're telling me. I'm sure glad that they're gone.
Do you hear that? What's that? Sounds like someone's casting spells.
Only 2 pencils. Not if the multiple magician has anything to do with it. Multiplicifio! 4, 6, 8, 12, 14. Now I, the multiple magician, have all the pencils.
Next we'll be learning about least common multiple. To understand least common multiple, we need to first know what a multiple is. If we think back to our multiple magician, he started with 2 pencils. Our multiple magician decided that 2 pencils weren't enough, so he added 2 more pencils. In total, he now had 4 pencils. Four is a multiple of 2. If we added 2 more pencils, we now have 6, and 6 is also a multiple of 2. We can keep going and adding more pencils 2 by 2. 8 would be a multiple of 2, And 10 would be a multiple of 2, because when we find multiples, it is similar to skip counting, and we are increasing by 2 each time. So all of 4, 6, 8, and 10 are multiples of 2, and we can keep going and going to find more multiples. A good way to remember this is that the multiple magician made the numbers larger. So the multiples of a number will always be larger than that number.
One way we can find a multiple is by skip counting or making a list, like we have done earlier today. So if we were wanting to find the multiples of 2, we could make a list by skip counting. So we could go 2, 4, 6, 8, 10, 12, 14, and the list would go on and on and on and on forever. But we don't want to do that because we'll be here all day. So we can also use the same strategy to find the multiples of 5. So we would count by 5s instead of 2s. So 5, 10, 15, 20, 25, and so on and so forth. Like we did earlier today, we compared these two different number lists in order to find what we were looking for. In this case, we're looking to find the least common multiple, or as it is commonly referred to, the LCM. So the least common multiple will be the smallest number that is similar in each line. We know that because least means less. So if we look at our two lines, the first multiple that we find that is the least is 10. So therefore, our least common multiple between 2 and 5 is 10. So now we want you to try this. So we're going to give you two number options, 4 and 5, or 6 and 7. And you could pick whichever number option you're more comfortable with and go ahead and make those lists of multiples to find the least common multiple. Go ahead and pause the video, work on that at your table, and then restart this when you're ready to go. Welcome back. So we're going to go ahead and review the first number choice, which was 4 and 5. And so in order for us to find the least common multiple, the first thing we need to do is list all of the multiples of that number. So I'm going to count up to, let's say, 24 for this first one. So 4, 8, 12, 16, 20, and 24. And the list would continue. So for 5, we'll also skip count by 5s this time, and we'll do 5, 10, 15, 20, 25. And then again, that list would continue. So if I look at my two lines of multiples, I notice that I have a least common multiple of 20, because everything before the 20 is not the same in the multiple line of 5 and in 4. So 20 is our least common multiple. The second number choice was 6 and 7. So to find the multiples of 6, we will skip count by 6. So we will start with 6, 12, 18, 24, 30, 36, 42, and so on and so forth. And for 7, we will skip count by 7 in order to find its multiples. So 7, 14, 21, 28, 35, and 42. And again, that list would go on forever. So if we look at our list, nothing is in common with these two multiple lists until we get to 42. So we know that this is again our least common multiple, 42, because there's no numbers that are the same before it.
Another way that we can find the least common multiple is by using our factor trees again. So for this section, go ahead and grab your sheets of paper and a pencil and follow along and write down the notes as we go. So the numbers that we are going to use to find our least common multiple are 36 and 24. We will start with 36 and break it down just like we did when finding greatest common factor. So we're just using our factor trees. So 36 can be split into 6 and 6 because we know 6 times 6 gives us 36. Neither of the 6's are prime numbers, so we can keep going. We know 6 is equal to 2 times 3, and we can go ahead and write that next to our second 6. We know that 2 is a prime number, and we know that 3 is a prime number because they both only have the factors of 1 and themselves, so we can circle those numbers. Next, we can write this down, our broken down form below 36. So 2 times 2 times 3 times 3 is the broken down form of 36. Next, we can move on to 24, and we'll do our factor tree in the same way. So 24 can be split into 4 times 6. Neither of these are prime, so we can keep going. Our 4 can be split into 2 times 2, because 2 times 2 equals 4. And our 6 we know can be split into 2 times 3, which gives us 6. All of our 2's are prime, as well as our 3, so we can circle all those numbers, and we are finished with that factor tree. So we know our broken down form is 2 times 2 times 2 times 3. Now to find our LCM, it's a little bit different. Instead of finding what our broken down forms have in common, we want to include all parts of both the 36 and of the 24. So first we'll start with the 24. 24, we want to take the entire broken down form and write it next to our LCM. So we have 2 times 2 times 2 times 3, and that we know gives us the 24. Now let's compare that to 36. So we already have 1 2, so we'll put a check mark next to that 2. We have another 2, so we can put a check mark. This next 2 is not part of the 36, so we can skip over that, and we have 1 3, so we can put a check mark next to that. So now if we look back at our 36, we're still mixing this 3 right here, so we can add that 3 onto the end of our LCM equation. And now we can see that when these line up, this section right here, the 2 times 2 times 3 times 3 gives us 36. So we have the full broken down forms of both of our numbers. So now if we were to multiply that all out, 2 times 2 times 2 times 3 times 3 is equal to 72 if we were to multiply that completely out, which means that our least common multiple is 72. Next, we are going to give you 3 problems to choose from to practice your least common multiple skills. The first option is 6 and 8, so finding the least common multiple between 6 and 8. The next is 12 and 20, so finding the least common multiple between 12 and 20. And finally, we have 12 and 14, so finding the least common multiple between 12 and 14. Go ahead and pick a number choice that you are comfortable with, or if you want to give yourself a challenge, pick a challenge number choice. And once you're finished with one problem, if people in your group are still working, go ahead and try another problem or another strategy. But once everybody is completed with one problem, go ahead and unpause the video and we'll get back to you. Welcome back. Since you are all rock stars at finding your factor trees, we went ahead and solved those out. And we'll just go over finding the least common multiple after finding the factor trees. So we can start with our factor tree of 6, which is 2 times 3, and then our broken down form of 8 is 2 times 2 times 2. So we'll start with the 8. We know that we need all 3 2's to find our least common multiple. So we have 2 times 2 times 2. And we can then compare that to our 6. So we have a 2 here, and we have that covered, but we don't have our 3 yet, so we need to add that 3 here at the end. So we can see 2 times 3 represents 6, and 2 times 2 times 2 represents the 8. And when we multiply 2 times 2 times 2 times 3, that gives us a least common multiple of 24. Our next problem was finding the least common multiple between 12 and 20. We can see that our factor tree told us that 2 times 2 times 3 gives us 12, and 2 times 2 times 5 gives us 20. So to find that least common multiple, we're going to combine the two. So we'll start with the 12, and we have 2 times 2 times 3. Then we'll jump up and compare that to what we have for 20. So we have a 2, which is taken care of, another 2, which is taken care of, and then we still need that 5. So we'll add the 5 onto the end. So in total, we have 2 times 2 times 3 times 5, and altogether that gives us a least common multiple of 60. Last, we were finding the least common multiple of 12 and 14. So using our factor tree, we found that 12 was 2 times 2 times 3, broken down, and 14 gives us 2 and 7. And it's important to point out that that 7 is a prime number. It can't be broken down any further because the only factors are 1 and 7, so we'll leave that right there. So to find our least common multiple, we'll combine our broken down forms. So we'll start with 12. So we know that broken down is 2 times 2 times 3. And now we'll jump up and compare that to the 14. So we have a 2, which is taken care of, but we still have the 7 that we need to add on to the end of our least common multiple equation. So once we multiply this out, 2 times 2 times 3 times 7 gives us a least common multiple of 84.
Alrighty, so let's go ahead and review everything that we've learned today. So today we learned about the greatest common factor, which is also called the GCF. And when we want to find the GCF, we are finding factors. So just remember the Factor Ninja when you are trying to find factors. So that Factor Ninja breaks down and chops up the numbers to make them smaller. So the greatest common factor is smaller than the original number. We also learned about the least common multiple today. So when we are trying to find the least common multiple, we are finding multiples. When we are finding those multiples, we want to remember the multiple magician. Multiple magician makes numbers larger by skip counting. The LCM, or the least common multiple, is larger than the original number. So now, last thing that we want you guys to do is complete an exit slip. You can go ahead and pick your own number choices, whatever you're most comfortable with. It could be a combination of different numbers that we used today, or it could be something that we didn't. And we want you to use those number choices and find the GCF and the LCM of that number choice. So thank you so much for participating and listening today, and happy GCF and LCM.